Welcome to the first installment of our video series on the AK5706, AKM's intelligent wake-up solution for voice products. The AK5706 listens for specific kinds of audio activity while burning just a few microamps of current. In the meantime, you can leave your system SoC powered down until we hear something interesting. My name is Bobby Tufino, and I'm an apps engineer here at AKM Semiconductor. Now, the AK5706 is a device with a pretty unique feature set, so we have a lot of ground to cover. For now, let's just have a high-level look at the part, and we can dive into the details later on in this video series. The AK5706 was initially conceived for products that use voice as their user interface, and as we all know, there are many of those on the market today. Most of them face a similar set of challenges, and that's where the AK5706 comes in. In this first case, we have a system built around an SoC with a built-in A to D converter. That SoC will remain powered on while waiting for voice activity. That means that it's going to burn through your battery pretty quickly because SoC power consumption tends to be quite high. It's kind of a non-starter for battery-powered products. In this other scenario, we have an SoC paired with some kind of a basic voice detection chip that doesn't do any noise tracking. That voice detection IC is going to stay on, but the SoC will only wake up once voice is detected. Now that's a little bit better than the first case, but you still have the issue of the SoC waking up too often due to false positives, because it's going to tend to just trigger on any kind of a loud sound. That just eats into your battery life. On top of that, you're going to miss any audio activity that happens while the SoC is booting up, so there's the potential to miss wake words or commands, or even something more important like glass breaking or something like that. When it comes to this type of system design, power consumption is key, so our goal is to keep the SoC asleep unless it is absolutely necessary for it to wake up. AKM's response to the problem of excess SoC wake-up events is the AK5706's Acoustic Activity Analyzer, or AAA. The AAA's Adaptive Noise Level Detector, or NLD, acts as a gatekeeper. It constantly tracks the current ambient noise level, meaning that a sound has to be louder than the noise floor by a user-customized amount in order for it to be of any interest. That is crucial, especially in a noisy room. Once the NLD has allowed audio content to pass through, the AAA performs analog frequency and time domain analysis to determine if the audio is relevant. You get all of that for around 30 microamps if using an analog mic. If the input meets the user's criteria, the AAA begins recording and the rest of the system will be woken up. If it does not, the AK5706 will just wait for relevant audio. The rest of the system never woke up. Less false positives means fewer SoC wake-ups, which means significantly longer battery life. The second big challenge with this type of system is missing audio activity that occurs while the SoC boots up. The AK5706's audio buffer addresses that very issue. Once relevant audio has been detected, the buffer will start recording and wake the SoC. It takes about 7 milliseconds to start recording upon reaching your preset noise level detector threshold. If the user wants to start recording only once they've got a positive classification, that adds 50 or 100 milliseconds to the startup time depending on the classification mode. Once your SoC has finished booting, it can read out the buffer contents over SPI, so you've captured the whole audio event minus a few milliseconds at the very beginning. That is much better than missing the entire boot up time's worth of audio. Alright, that about does it for this intro video. The AK5706 is in production now, so you can head over to akm.com and take a closer look at the block diagram and grab the datasheet while you're at it. In the next video, we're going to go into the details of the Acoustic Activity Analyzer itself and tell you all about how it works. It's really good at distinguishing between all kinds of different audio, so it can do a lot more than just voice detection, but more on that next time. Thanks a lot for watching.